Dear M1 students, hi everyone again. We are continuing in explaining the chapters, which is the last chapter in M1. Before we start, I pray for you, and especially in this holy month, Ramadan Kareem, dear students. We are finishing the syllabus of M1 this week, hopefully. We are in the last chapter of M1, which is vectors. Mainly our work, dear students, in this chapter, we use the formulas of kinematics in the first chapter to find displacements and velocities and acceleration in statics and dynamics, forces. So our work in this chapter is to find these quantities as vectors, to write and describe them and find them as vectors. But we'll start today. The lesson today is introduction, and it's mainly reminding you in some skills from O level. So I'll not make the lessons of this chapter so long. We'll be doing our best to make them as short as we can. The first thing that we'll be starting with is the IJ notation. When we describe the vector as IJ notation. IJ notation. We know from O level the unit vector. We remember the unit vector, which is a vector of length of 1 unit. 1 unit. We call the unit vector the length of 1 unit as explained in blue here. I'll do it again, but in black to see it. This vector here, which is I here. Do you see this I? To see it on a grid like this. So the vector I is the unit vector in the direction of the positive x-axis. It's called I, or to the right, or east, as you wish. All of these words will be used in this chapter. So the positive direction of x-axis is east, due east. And since negative I, the same length unit, which is this one, but it is opposing the direction of I, having the same length unit, so it's called negative I. The same for y direction, or direction of y. We call the vector along the positive y-axis. Positive y-axis J or north, in the direction of north or due to north J, and the vector opposing to it, which is down or due to south, negative J, as shown on grid here. I, negative I, J, negative J. Our work in this page will be explaining, writing, or describing each of the vectors V1, V2, V3, V4, as shown in the diagram, using IJ notation. So look at the vector V1, for example. V1, which is the vector OA. OA, to move from O to A, we go 4 times of I. Look, 4 I's. We mean 4 steps to the right, 4 units. So I'll do it in blue to see it here. 1, 2, 3, 4. So we say that OA, which is shown here, first one, vector V1 or OA is 4I. And at the same time we go 2 units up, 1, 2. So it's 4I plus 2J. We'll do the same for V2, which is OB. Just yes, this is the vector OB. which is 1, 2, 3, negative, because we went due west or left, so it's negative 3I plus 3j. 1, 2, 3 to the left, 1, 2, 3 north or up, so it's negative 3I plus 3j. The same for V3, you got the idea now. How many units we go? Look, 1, I'll do this in different color, 1, 2, 3, 4 to the left, so it's negative 4I. Down, we went down 2, so it's negative 4I, negative 4j. The same for V4, it's plus I or I because it's 1 unit to the right, or the vector EF, minus 2j, minus 2j, plus I, look here, plus I, minus 2j. This is the meaning of, or this is the notation of IJ notation. The part that we'll be focusing or concentrating today on, we must remember, we have to remember as AS students some skills or properties or definitions from O level, but using them or writing them in IJ notation. Mainly we must remember the magnitude or the length or the modulus of the vector. Parallel vectors, parallelness of vectors. What do you mean by, and how do you solve problems with parallel vectors and bearings? Mainly we'll finish this for today, to continue soon tomorrow, after tomorrow inshallah, with the left parts in chapter 6 of vectors. The first definition we must remember, if the vector V is equal to AI, now this is mainly we'll be using and even be asked in the past paper problems or exams questions, IJ notation, AI plus BJ. Then the magnitude of the vector V, we write it in this form as shown, in this form. This means the magnitude of the vector V is equal to A squared, this A squared, plus B squared under the square root, using Pythagoras. We know this from O level, and will be explained well in the examples now. A bearing, we must remember what is the bearing. It almost comes in every question, almost the first part in the vectors questions in the exams. So the bearing is an angle drawn from north clockwise, always. This is the definition of bearing, is an angle drawn from north clockwise. Let's see in the examples how the questions may come in the exams. Example number 1, find the magnitude and the bearing of each of the following vectors. Vector number 1, V1. V1 equals 3I plus 4j. The magnitude of the vector, we use this notation, which equals 3 squared plus 4 squared under the square root, which is 5. 5 length units. To find the bearing, we recommend to sketch the vector in all the questions with bearing. If it's not, you sketch it. So to find the bearing, we sketch the vector first. Of course, we don't use a grid in M1 exams. So how to show the examiner that you are sketching the vector and you know where is its position or its direction. So we just show 3I means 3 on the x-axis, 3, plus 4j, so you just show 4 on the y-axis. So to find the bearing, we can do many methods, 2 methods mainly, but we'll do the shortest ones. We can find, this is the vector V, this is the vector V1, and this is the angle. Look, this is the north, which is the positive y-axis, and this is the angle alpha. We move, look, clockwise, clockwise, clockwise from north. So the angle alpha is the bearing we are finding, which can be found in one step. Alpha is equal to tan inverse, since tan alpha is 3/4. So we do shift tan 3/4. It's 36.9 degrees. We round to the nearest degree, getting the bearing of the vector V1, 37 degrees. 37 degrees. The vector V2, -5 or -5i. So look how you show -5i plus 12j. So we'll form triangle. This length is 5 and this is 12. Yes? So what's the bearing of this vector? What's the bearing? This is the north, which is the y-axis, as drawn in black. So I label it again. We move from here clockwise. Look, we move clockwise till we reach the vector V2. Since we round here 3 turns, so this 90 degrees, this is 90 degrees, so this from here to here is 270. So only to find the bearing of vector V2, we find theta, the angle theta, the same idea, the opposite is 12, the adjacent is 5, so theta is equal to tan inverse 12/5, which is 67.4 degrees. Rounded to the nearest degree, you will get 67. By adding it to 270, you'll get the answer. We can find this angle subtracted from 360, both work. We can find this angle, 90 minus theta, this one, which is tan inverse 5/12, 360 minus it, the same thing. The same thing, but these two methods more straightforward to the students because the triangle is drawn, so you can find it directly. The last part for today is about parallel vectors. We did study, dear students, as AO level students, like main idea of parallelness of vectors in O level, but we'll go deeper this time. The questions come, as will be shown in the next videos or next lessons. The questions in ES come deeper and harder. But we must remember for today, what do we mean by parallel vectors? Okay, if third definition for today and the last one, V1 is A1i plus B1j, and V2 is A2i plus B2j. Then V1 is parallel to V2. The vector V1 is parallel to the vector V2 if the ratio of the I component is equal to the ratio of the j components. In simple language, we divide the coefficients of I. A1 dividing by A2 is equal to B1 over B2. Then the two vectors are parallel. And we may discuss or state the parallelness of vectors. This from O level. We know this from O level. If a vector is a multiple of another one, or if a vector is multiplied by a constant number, we call it k in this example, or this definition, where k is a constant. So let's see two examples that finishing the lesson today. Example 2, are the vectors A is equal to 2i plus 5j and the vector B is equal to 6i plus 15j parallel? Explain your answer. Explain your answer or justify your answer. The answer is yes. Why? So we may do two ways in this question. Example 2, First one, we just divide 2 over 6. Is it equal to 5 over 16? Sorry, 5 over 15. 2 over 6 is equal to 5 over 15. Yes, when you simplify it, simplify both fractions, you get third. They are equal. Both of them is equal to third, and they are equal to each other's. This implies that the vector A is parallel to the vector B. Or we may do factorize one of them. Can I write one of them as a number multiplied by the other one? Yes. Look, if we factorize the vector B, you have 6, 15. If you put 3 as a common factor, you will get 2i plus 5j, which is the vector A. So this will be given, the vector B is equal to 3a. This is the meaning by k in this definition. So B is equal to 3 times the vector A. So A and B, they are parallel vectors, or the vector A is parallel to the vector B. The last example for today, example 3, another way in asking, different way. If the vector A is equal to 3i plus 4j, and the vector B is I minus 2j, this is one of the more important questions. Find k if A, when A plus KB is parallel to the vector I plus 3j. You are given two vectors, I, 3i plus 4j, and the vector B is I minus 2j. Find k. He gives expression in the question. The vector A plus k times the vector B is parallel to this vector I plus 3j. He wants k. We want k. Only will do one step, one main step. We'll be starting with the vector that he gives us, A plus KB. Just write A in ij notation like he gives us in the question, and B as well. By expanding k, in this expression you'll be getting A plus KB is equal to, what did we do in this step, which is the main step in the question, this step here? We write the vector in ij notation, I component plus j component. I plus j. How did I do this? This is 3i, this is ki, like terms. So 3i plus ki is equal to k plus 3i. The same for j components, 4j, negative 2kj, so it's negative 2k plus 4j. Now the question tells us that this vector is parallel to this. Now notice that, dear students, that we cannot use the second part of the definition, which is this one, the multiple one, in this example. So only we can use in this question this method, the first one, A1 over B, or A2 is equal to B1 over B2. But so by dividing, only by dividing the I component, K plus 3 over 1, when we say I, we mean one I. Always we have one exists there. Is equal to the J component, which is minus 2k plus 4 over 3, which is the J component in the parallel, the other parallel vector. By solving this simple equation, by cross multiply, expand 3 times 3k plus 3, which 3k plus 9 equals this. So 3k plus 2k is 5k, is equal to negative 9 or minus 9. So k is equal to negative 1. Of course, when he says prove that or find k, we are given this. Can we check are they parallel? Let us see, which is the last part in this question. We can check, dear students, we can check. So a plus kb is equal to, this is the vector, a plus k b. Just substitute or replace k in this by the value, equals what? Equals minus 1 plus 3i plus negative 2 times minus 1 plus 4j, which is 2i plus 6j. When I replace k by its value, we'll get this. Is this vector parallel to I plus 3j? Yes, it is. Why? Different color here. Just put here 2 common factor. Let's use the other way of stating the parallelness. So the vector is equal to this 2 parallel vector. 2 is a factor, common factor, so I in the brackets 2j. Sorry, 3j. Yes, 3j. Let me just write it neatly. Which is the vector given in the question. So a plus kb is parallel to I plus 3j when k is negative 1. This is the idea of parallelness of vectors. Of course, the questions in M1, they come harder than this and deeper, but we'll do this in steps, in stages. So watch this video to enable yourself, to help yourself to move smoothly to the next ones, to be able to do past paper problems, to be ready for your predicted grades or your exams in October or next year. You don't know what may happen. We pray in these holidays and always Allah Azza wa Jal to remove this pandemic and to finish this circumstances you are in. I wish you and your families the best, dear students.